Okay, homework 1.6, determine the quadratic equation given its roots. So number one asks, find the equation of a quadratic function that has the given x-intercepts and passes through the given point. So as soon as we're given x-intercepts, we have to use factored form. And then this question is just asking us to express it in factored form. So just doing the work. Okay, so for A, we're given the two x-intercepts, 3 and -5. So we're going to start with the general form of the equation, and we're going to sub in 3 for R and 5 or -5 for S. Okay, just remember that there are built-in negative signs here. So as soon as you put it in, the sign for 3 and -5 are going to switch. Okay, and we are going to sub in an X and a Y, the point that it goes through. So I'm going to do this in one shot. Okay. The value that we're actually solving for is the A value. So X is 4 minus 3, and then 4 is going to turn into a plus 5. Oops, 4. Okay, so let's simplify those brackets. 4 minus 3 is 1, 4 plus 5 is 9. So this side here is actually 18 equals 9A. Divide out the 9, A equals 2. So our equation for this one is actually just y equals 2, x minus 3, x plus 5. All right, for B, the x-intercepts are -6 and 2. So when we sub it into this equation, okay, this is going to be R and S. So it's actually going to turn into plus 6. And then -2. Okay, and we're going to sub in, okay, so it says y-intercept of 3. Okay, so if you're thinking about a y-intercept, this is like a throwback from grade 9. You find that y-intercept by subbing in x equals 0. So essentially, the point is 0, 3. So 0, 0, and then 3. Okay, and then we just simplify. So this is 6, this is -2. We get 3 equals -12a, and then we divide it by -12. Okay, so I get -1/4. So the actual equation is y equals -1/4, x plus 6, x minus 2. All right, so C, again, I'm going to start with the exact same formula, the factored form. And we have x-intercepts of 0 and 3/5. Okay, so we're going to go -0, -3/5. And then we're going to put in the point x, y. So the x's are 2's and the y is -28. Okay, so -28 equals a 2 times, what is 2 minus 3/5? 7/5. Which is 14/5. Okay, cross multiply. 28 times 5 divided by 14, I get 10. So -10, a equals -10. So this equation is y equals -10. Oh, well, like x minus 0 and then x minus 3/5. I'm going to take this one step further, okay? So when we have x minus 0, that just cancels to x. So that's fine. Here's the other thing. This is actually not like true factored form, because if you were to ever factor this, like the original, it would never show up as this. So what this actually is, because the 0, like if you go x minus 3/5 equals 0 and you brought that over, our actual x-intercept is 3/5, right? You have to think, how else can we get 3/5? How else can we display it? It's actually 5x minus 3. I always remember that this denominator, you just put up 5x minus 3. Because again, if you were to branch that off, you're going like a little bit backwards, you would bring it over, and you'd have 5x equals 3, and divide by 5. Okay, so if you're looking at solutions or the back of the book or wherever, you may see the answer presented like this. For the scope of this course, I'm going to accept the negative 3 over 5. Okay, find the equation of a quadratic function that has the given x-intercepts and passes through the given point. So the exact same question, however, this time we are going to express it in standard form. So when we take a look at these, like all of these examples, A, B, and C, they all have radicals in them. So they're all going to take on approximately the same form, okay? So 2A, we're still going to use the factored form because we're given two factors, okay? So the two factors here are 3 plus root 6 and 3 minus root 6. When we write those in, keep them in brackets because we're treating this as one full number, okay? So, and then this is x and y. So I get negative 10 equals A, 1 minus 3 minus root 6, and 1 minus 3 plus root 6. Okay, so quite long, but all we have to do is solve. Okay, we're going to solve for A. So we're going to distribute the negative sign into both of these brackets. 1 minus 3 plus root 6, 1 minus 3 minus root 6. Okay, we're going to simplify a little bit. 1 minus 3 is negative 2. And 1 minus 3 again is negative 2. Okay, at this point, you should have difference of squares. Negative 2 plus root 6, negative 2 minus root 6. Okay, so if we go ahead and expand these, because they're difference of squares, it's going to get rid of the radicals. So we're going to have 4 plus 2 root 6 minus 2 root 6. And then we're going to have root 6 times root 6, so minus root 36. Okay, again, because of the difference of squares, these two terms are going to be identical. If they're not, then you did the multiplication wrong. Okay, so now we have 4 minus 6, because root 36 cancels to 6. So we get negative 10 equals A, negative 2, divide both sides by negative 2, A equals 5. Okay, so this question is a little bit different because we have to expand some of these brackets when we're writing in standard form. So let's rewrite this actual equation just in factored form to start. Y equals 5. And I'm going to write this form of it because I had already this form. I already expanded it. So x minus 3 plus root 6. X minus 3 minus root 6. Okay, so keep the x's and keep the y's in there. Now we are going to, we'll kind of foil this, rainbow it. Okay, we're going to multiply these two trinomials. X times x is x squared. X times negative 3. X times negative 6. Sorry, root negative 6. Negative root 6, that's better. Negative 3x plus 9. Okay, so we're just applying the negative 3 into every term in the second bracket, and now the root 6 onto every term in the second bracket. Okay, and now let's simplify. So there's going to be a couple that we can cross out. 3 root 6 minus 3 root 6. X root 6, negative 6, negative x root 6. And now let's collect like terms. So we only have one x squared term. We have negative 6 x's. And we have 9 minus 6, which is 3. So I get y equals 5x squared minus 30x plus 15. Okay, 2b. So now we have the x-intercepts y plus root 5, and then we have y minus root 5. Okay, and passing through the point 3, 6. So 3, 6 is going to be our xy, and we're going to have 1 plus root 5, 1 minus root 5. Okay, so y equals a, x minus r, x minus s. I'm going to sub all of these in one shot. 6 equals a, 3 minus, remember to bracket these, okay? 1 plus root 5, 3 minus, 1 minus root 5. And then all we do is solve for a. So let's distribute these two negative signs into the bracket. 3 minus 1 minus root 5. 3 minus 1 plus root 5. I'm going to simplify the 3 minus 1s. So 2 minus root 5, 2 plus root 5. And now this is difference of squares. So we're going to expand this. Again, we're solving for a, so we have to expand everything and then divide it out. So we have 4 plus 2 root 5 minus 2 root 5 minus root 25. Because it's difference of squares, you're going to be able to cancel out this middle term. And we're left with 4 minus 5, which is negative 1. Okay, so we're going to divide both sides by negative 1, and we get a equals negative 6. Okay, so I'm going to rewrite the equation, but with a negative 6 in for the a value. Okay, I'm going to change colors. At this point, we have this in factored form, but we don't want it in factored form, we want it in standard form. So we have to expand everything. So let's expand this x into the second bracket. X squared minus x plus root 5x. Okay, let's expand this negative 1 into every term in the second bracket. Right, we're just flipping all the signs if it's multiplying by negative 1. And let's distribute this negative root 5 into the second bracket. So negative root 5x plus root 5 minus root 25. Okay, again, we're going to be able to cancel out 4 of these. So root 5x minus root 5x, root 5, negative root 5. Do you notice that there are no roots left here? So x squared minus 2x, then 1 minus 5 is negative 4. Okay, and then we just expand. Fully standard form is completely expanded. Okay, so for 2c, we have two x-intercepts. They are 7 plus 2 root 3. And then 7 minus 2 root 3. Okay, so there's no additional point, but a equals 1. So this is actually kind of already done for us because there's no, if we write out the base 1, a equals 1, we're going to have x minus 7 plus 2 root 3. And then we're going to have x minus 7 minus 2 root 3. Okay, but this one's already done for us. We don't have to actually solve. Oops, it is like that because a equals 1. So all this question wants us to actually do is put it into standard form. Okay, so y equals, so if there's a 1 here, I'm going to actually leave it out. And I'm just going to distribute this negative sign into the bracket. So x minus 7 minus 2 root 3. Okay, we get x minus 7 plus 2 root 3. Okay, and now we just expand. So distribute this x into every single term in the second bracket. We get x squared minus 7x plus 2 root 3x. Okay, now distribute this negative 7 into every term in the second bracket. So negative 7x plus 49 minus 14 root 3. Okay, now distribute this negative 2 root 3 into every term in the second bracket. Negative 2 root 3x plus 14 root 3 minus 4 root 9. Okay, just like all the other ones, we should be able to cross out 4 things, like 2 pairs. So 2 root 3x minus 2 root 3x, 14 root 3 minus 14 root 3. Okay, this 9 cancels to a 3, and these two are identical again. Okay, so we have x squared minus 14x, and then we have 49 minus 12, so plus 37. Okay, and then that satisfies a equals 1 as well.